So it's time to do some animation for the container, because we need the container to follow up with the wheel movement. And the way you can do that is that we can animate the container directly or link it with the animation node here, or the bone of the whale. I don't prefer these. I prefer to create just a random object, which is this box in my case, and then I can animate this box. Then I can link this container to the box. In that way, I make sure that I can change the animation independently from the container. Also, I can hide and unhide this object as whenever I want. Just make sure it's not a part of the simulation, as we will see now. So what I did is that I animated this box to be able to move with the wheel. So I will expand this. I will hide the grid by pressing G on the keyboard. As well, I will hide the C. So now, if you can see, we have this box, and if we run the animation, I will hide the camera as well because I don't want to see it. You can see that the box is moving almost with the wheel. Here it looks like it's not moving much. It's easing its movement. It's important, as you will see. And when it starts moving, it doesn't start suddenly, but it starts from zero, rising its speed to match the whale speed. If you look at this from side viewport, we will understand what's happening. So at the beginning, everything is contained within the container. We don't need to really speed much. But now we have the same speed, making sure the container is around the whale as we will attach it later. And here the whale is under the water, so no need to move the simulator. So let's display the sea level again and make sure we go to the first frame and link this container to the object. Now if we will move the time slider, everything is working well. Whale is inside the container, and here the whale is under the water, so it doesn't matter if it's here, but everything is outside the container. Everything happening here is still happening inside. Now just let's see something which is extremely important. Let's select this object and look at its animation. If I will just maximize this, everything starts with ease. We don't suddenly move this from not moving into moving very fast. That's extremely important. And we end up everything smoothly also, like we did here. If you notice, we went here, then we smoothed everything, like everything is slowly stopping. Because if we suddenly stop everything, the water inside this container gonna stop suddenly also, or gonna react to this sudden movement, which gonna create on the edges of this container, as we will notice later, it will create some kind of foam and splash particles, because there will be a difference between the movement of the liquid inside this and what we suppose should be the same speed of the liquids outside of this container, which is controlled by, again, this factor. Dynamic motion inertia. So to make sure that we don't have this effect, we need to slow down this whenever we start the animation, and whenever we do any change on the animation, or when we end the animation. As you can see, it's not straightforward, so we have some curve like this. Also, we can rotate this, do whatever we want, and it will work just fine. Again, I changed the dimension of this container a little, just by making sure it wraps everything roughly. So I give it a head here and back, so I make sure that everything generated is taking into consideration the space to move freely. And also for the height, if we look at the side view, I don't really need to take that much height. Although the whale is moving up, it's moving slowly. So most of the water going to be dropped here, and eventually we'll have the whale without the water here when it's here. So to just to speed up things now, I will just reduce this into this value, so there's no need to calculate anything here. Later I can of course make this bigger and start calculating things in a different way. But for now this is all I need, and I can start with the number here because the number is big, and as you can see 45 millions is a big number now for the voxels amount, and that will just slow down everything for us. So I can just maybe decrease this to 0.02, which can create 24 millions, which is big enough for me. Now before we start our simulation, we need to understand what does it mean to start the simulation and what are the things which we have to take in consideration. So from this, all we need to go is to the scene interaction, and here we need to include what are the objects which we need to take in consideration when we simulate this. What are the objects which we need to interact with the liquid itself. So as I can see, it's only the whale here. I don't even need to include his teeth or eyes because they will be mostly underwater. So I don't need to include these. By default, PhoenixFD contain everything inside this container in the simulation, which I don't need. All I need to do is to say include list, and I can just add this whale. As you can see, the resolution or the number of faces for the whale is big. I prefer that rather than just to work with a proxy. Why? Because it takes into consideration the small details, and it's even useful when taking into consideration the steps, means that always in comparing with the smallest step here of the container. So that's good for now. Another thing to set up is to go down to output. This is the place where we can define where the simulation file is gonna be, and basically PhoenixFD will create a simulation file for every frame, not every step. Again, if we go up here, we have steps in the dynamics, steps. So even if you increase this number to 3 or 4 or 5 to calculate more accurate movement, even we are calculating between the frames, PhoenixFD will only create a simulation file for every frame. So just take into consideration, and let's continue. So to set up this, we only need to press this and browse, go into a new folder and just rename this. So I will just call it rising whale. Of course I can save this, just press save, and it will save all this into this directory. But also I can do something, just I can press this and add 4 hashtags, which defines the buffer, which defines how much zeros I will consider beside the frame number. That's just small detail which you can see later. So I say save, and this is all I need to do to start the simulation. Now let's go back here, make sure we choose this. Other than that, I don't need to do anything. Just I will run the simulation and make sure what is the height of the water here. If I will need to change it, because this is the height reference which I want the water to be, but basically what I did here is that I put a random number which is 20, and if you look here, it's almost 50. I would say 40, maybe 41. That's it. This is what I want the water level to be, and after I simulate a little, I will know exactly if this is a right number or not. So this is a big number. Let's reduce this to have like 6 millions voxel or cell, and let's run the simulation and see what's gonna happen. So to run the simulation, all I need to do is to press start. But before that, let's save this scene. So I will save the scene in here, and I will call scene files. So this is the start 2, which we have all the container, basic container ready, and we will start our simulation. It's important to save things. I would say that Phoenix is rarely crashing, but just to make sure that you have everything right. So all we need to do is to press start here, or we can go here and press this button. Just make sure you are on your Phoenix FT liquid and run it. And you can see here that we have steps, which is 1, and we have the total amount of simulation files, and we also can move and navigate and see everything during the simulation. So let's see here. Basic thing, the first thing we will notice that it's filled till here, which is good, but we need to fill it more a little just to make sure that we are almost on the grid. And the second thing, it doesn't matter if our object is intersecting with the water body, because that will be taken into consideration. The water will not come into the geometry because the geometry is already solid. So that means all good. Now again, let's see the numbers of particles. So we activated wet map, means that we will be creating some particles from wet map. But we didn't activate any foam, splash, or mist. That means we didn't have any. But the main thing here, before we activate anything, and we shouldn't activate this even, just to watch the amount of particles. We have 2 millions and almost 700,000 particles, which is fairly low. But it will give us an idea about how the liquid is moving. Is there any problems? Is there any like particles floating everywhere or just flying everywhere? Do we need to change anything? Basically, this all we can get from here, basic information. And I would say before we continue here, I prefer to stop the simulation and to go back at the beginning, and also to come here and deactivate the wetting. Of course, the display for everything here, we will just go and see how we can display everything here, but basically I don't need this amount of particles to watch everything. Although it's very fast and simulating very fast, all I need to go is to go to the grid again and press this again. So I need just 3 millions to create everything, and let's go to preview. Preview is where the place which we can show the particles or the mesh or everything, and just to see how everything is looking. And as you can see here, we have auto reduction exists. So this is not the actual number of the particles. If we will move this and see it from perspective, we will see that we can hide basically the sea level. Just make sure to go to dynamics and increase this a little, just maybe 41.5, just to make sure that we have higher level of water to match the reference. And we can go here. If we see the total amount of this, we deactivate auto reduction and we just bring this into 0. This is the amount of particles we have, which is fairly good. It looks good, but for final simulation this should be a couple of millions. Not a couple of millions, but several millions. At least we are talking about 7 millions and more. But for now, all we need to do is to make sure that we have this set to 5, 4, 3, just to see the general shape of the water, and it's not heavy on the scene, because as much as we increase this, it will be heavy. Also, I don't need to show the mesh because we didn't create the mesh yet. Later we'll create it. And here I'm activating the liquid, and I have other particles to see. If I will go to width map, you can see it's in red, and as you can see here, it's in red. If we need to see it alone without anything, you can just go here and deactivate the liquid, and we can increase this or decrease this number to see how much width particles, which is basically the particles which indicates that this whale is touching the surface of the water. We use this to just change the sense of material of the whale to make it look like it's wet. In our situation here, most of the time the whale is inside or touching the water, so it doesn't mean much. But in some situation where the whale is jumping and leaving the water and we see a lot of its body outside of the water, this comes into handy because it will dry. So let's just ignore this one. I don't need even to show it. And let's just go to liquid and show the liquids. Again, let's reduce this number to 2 or 3 just to make sure that we don't have much of particles in the viewport, which is gonna slow everything for us. That's for now, and all I need to do is to run the simulation and see how everything is acting or reacting here, and later in a later stage I can just go and activate the foam, splash, the mist, and even the width map to see the amount of particles to be able to judge everything. From this we will learn how to make sure that our particles are enough or not just by looking at this. And my rule in this is that you usually have certain amount of liquid particles, which if it's enough, based on that you will know exactly the amount of foam, splash and mist. So let's run the simulation again and see what we're gonna get. I will stop the recording now and I will come back after just seeing some results. So now let's see, we finished the simulation. Let's see the results. If I will go back like here, yeah, I can see that if I will look at it from the side view, it's converted to left. Let's see from here, hiding the grid, and also I'm gonna hide the box. Let's see now. You can see that everything is going really well because the whale's movement is slow. Now we'll continue, and we see that the particles have been cut here because the container is not that high, but we have very amazing and beautiful leading wave. Let's continue. Now this is nice. Everything works really well. Now the whale here in this area gonna speed more. Everything seems good, but now we can see it. So the wave here has been cut. So we suppose that we need to increase this in terms of height, and also we should account for the foam and the splash. So we will need to create more foam and splash here, and they will be on top of this. They will be high more than this, so we need to account for that. But eventually this is what we need to account for. Now let me do one thing. So to understand more the relationship between the liquid and the whale, we need to have all the parameters which affect the relationship between the two, and one of the main things is the interaction factor between the two. So if you right mouse button on the object here, which is the whale body, we'll find that motion velocity effect is a factor which defines how much the whale is affecting the liquid. We can reduce that to 0.4 or let's say 0.35, and see if that will affect much on this scenario. I don't think it will do that, but let's do that. Let's simulate this and come back and see the result. So finished in 15 minutes, and let's see now. It's almost similar. So we don't have really big difference, because if we come here, there is a clipping, still the same clipping. The height of the wave is the same almost, and not much of effect happened here. So let's study the case here. So when the whale is going slow, we have good interaction, we have leading wave, which is good. We have also a good interaction here in the back. Everything seems good, and if you look at it from top, you can see also that everything is almost contained within the box. Nothing is going out. Maybe a little here, we can expand it a little here, and also in the front here we can expand it a little right and left, but all of it is contained. The only thing which we really need to take in consideration is to increase the height here. Now, before we continue and increase the height, let's understand something. There is this three factors which affect everything here. If I wanna reduce the height of this wave, one thing I can do is that I can go and increase the gravity. This is one solution. I prefer always to keep things by default with the scale as much as I think it should be. The things which I can change, and it can change the reaction, is the timing. So if I will change the time and make it slower, that means the whale will be slower, and that will affect the water. It means that the whale will cross the same distance. If I decrease this into half, means the time will be slower twice. Means it will cross this distances with double of this time, means slower. And everything gonna be slower, so the reaction gonna be slower. That decrease the height of the wave. This is one factor. Another factor here is to take in consideration with the scale of the scene. So if I will increase the scale of the scene, means the height here is not the height before. Everything gonna be the same, but that means I will have more distance. And based on the same steps here, it means that 3D or phonics will have the chance to calculate in different spaces, because I have bigger geometry. So these are the things which we have to take in consideration. The speed of the object, which take in consideration the time and the scale of the scene, which is important. I tend to simulate everything in my scenes with slower simulation, slower animation. That means I will get something stable more, and I don't need to increase my steps per frame, because this is exactly the same. So if I have 2 steps, means I'm calculating between each 2 steps here in each frame. It's the same as if I just doubled the amount of frames here. So taking all this in consideration, all I need to do is to go here and increase the height of the grid. But before that, let's read the numbers. The liquids are 1,264,000 almost. So that means it's not much particles. Of course, we can increase the display and see the total amount of particles exactly in the viewport by going here and just bringing this to 0. So we see exactly how the particles are looking like. So I can make it closer here and see the leading wave which we liked. That's it. It's nice. No much of noise here, but that's again something we can take care of, especially when we create the foam and the splash, which gonna interact by itself to the liquid and will change its behavior, creating some swirls and some additional noise. But this is nice at the beginning, and in the end or here you can see that there is also interesting shape of the water. See, it's slow. The viewport gonna be slow because I have a fair amount of particles. I can expand it from here and here, but that's, you know, it's okay for now. So let's increase this into 3 as example to speed up everything, and let's increase the height. And just notice something while we are doing this. So this doesn't mean much. Here's the important number, so I can do increase just by pressing here 1 2 3 as example. This is good, but I can even go down here to 19, and I will have something like 30, almost 30 million voxels. Again, I can go here and decrease this number a little, and in the same time increase the height to 105. That will be enough for me. Of course, I can always give it some buffer to have more height, and from there I can start simulating everything. In that time I will make sure that all my liquids are contained within the borders. Of course, I can increase this a little also, so 870 can be 900, and this one can also be 380. But that's it. For me, everything here is described well. All I need to do is to figure out what kind of foam and splash I need to create here. So let's go and discover more about foam and splash and how we can change these and create something decent for this scene.